When editing a video, there exists a possibility of leaving one's blunders on the cutting room floor, but it's dishonest, and that's not me. That's hardly ever me. So I'll tell you now, and you won't have to suffer the disappointment which I did. This first bold attempt to create a rear tub for Panther's Model 50 Villiers, commonly known as a parrot beak, has failure written all over it. There's a short inner section of guard doing the real work, but we are creating an outer mudguard, the crowning glory of this Design Council award-winning showpiece. No, I'm not joking. A bit of sticky tape anchors the paper, nothing anchors the scissors, and I rub along the edges to leave a witness to pencil mark with a centre line for trimming. Cut the pattern oversize by a ½ inch, that's 12 millimeters to you youngsters, or 12.7 millimeters for nitpickers, and this allows for trimming the shaped panel to size. If you look at the excess material indicated by flappy folds of paper, you'll see just how much has to be lost by shrinking the edge and gained by stretching the centre of the panel. Too generous with the oversized blank, and we'll struggle to shrink a mass of spare metal which will be trimmed off anyway. Allow too little overlap, and you'll either start again or suffer the embarrassment of having to put back what you removed, as I did with the side panels. Didn't I mention that in part 2? Must have slipped my mind. This is pattern tessellation, one of the metalworker's special skills for getting the most out of a sheet of 0.9 millimeter cold rolled steel with a minimum of waste. Computer-aided design packages do it automatically, denying us all the satisfaction while experiencing none themselves. How can that be right? The pneumatic shear saves a deal of elbow grease, leaves a clean edge and scares off cats. Then it's in with the earplugs and give it some what for in the hollow log. For woodworkers, that's sycamore, and its flat-topped companion piece is ash, both locally grown. A botanist, should you find one in a metal workshop, would tell you Acer pseudoplatanus and Fraxinus excelsior. Blows in the centre stretch it, while puckers along the edge create opportunities for shrinking. The sandbag, using my back to basics philosophy, is stitched from a leather apron filled with clay pit sand. It's not the best surface for making the more extreme changes, and I soon swap it for the hollow log. Most of the heavy work is done with the simplest of equipment. For shrinking, the technique is to create a fold and attack the inner point at sides and end. Beat it down, working steadily towards the edge of the blank, and taking care not to turn the fold over on itself and put in a crease which will be difficult or impossible to remove. Hold on, someone at the door.
I didn't even know what it looks like you picked it up anyway.
Yesterday, yeah.
Yeah.
Got it. Yeah, that's right. Thank you.
As I was saying when I was so rudely interrupted, the folds running towards the edge resist being flattened, and so the material closes and thickens in between. I have a good try at forming the half mudguard, but in the end I give up. There seems to me no possibility of losing all that extra material. Yes, I could have been sneaky and scrubbed the video's first hour, but felon forbid that I should be accused of cheating. So I rip it up and start again, this time with a guard made from 3 instead of 2 pieces. This centre section is formed by the same method, but with much less to gain at the centre and to lose at the edges. Basic shrinking is followed by work on the sandbag, beating the centre to stretch that further. I refine the curve around a section of steel tube and knot flat the front where guard meets frame. A twist in the hands to settle the arrangement, and we're ready for a preliminary trial on the moulded guard. This is not strictly a buck, which would be fractionally smaller than the finished item by the 0.9 of a millimetre thickness of the steel, but I'm happy to ignore such a footling discrepancy if you are. So to the wheeling machine, the original title for this tool. It was in America, whose metalworkers more commonly used hammer forming, that they called it the English wheel. Ironing metal in this way is surprisingly effective, and to my hands most satisfying. I had use of a similar wheel to this at Leeds College of Technology many years ago, and was so impressed with its neatness and rigidity compared to those box section that I took measurements and fabricated my own. Cast iron framed wheels are superior, but well out of my price range. The upper wheel is from an old chicken hut. Rollers are turned from 2-inch steel bar running on ball bearings. Wheeling does alter the part's area value as well as its arrangement. See Part 1 and the Ray Shaleen Pro Shaper YouTube channel for an explanation of these terms. A trial tells us how we are progressing, and it's back to the beating hammer for more extreme changes. This tool is another way of creating folds precisely where you want to shrink. Sequences are shortened, as they say in advertising, but with the centre following the profile of the moulded glass fibre, we're back to the side, trimmed and reworked. Discoloration is the result of a propane torch on the initial trial. Heat, while it anneals aluminium, has next to no softening effect on mild steel, but it does warm the winter workshop. These reverse bends follow the frame tubes. As the shape gets closer, I use a shrinker which clamps the steel and gathers it. Downside is the scores it leaves along the edge. When I'm satisfied that the shape agrees, I clamp it to the buck, lay the centre section on top, scribe the edge and trim it before moving to side 2. I aim to perfect the curves over the frame tube and anchor the shape there. This shows more accurately where the rear end needs more work. Most of the compound curve is in the tail, the front section being closer to a simple bend. I begin to form the first part of this and run back into the rear with more shrinking. Keep offering work to the buck to get an idea of the changes required before you go too far. In theory, you can stretch the over-shrunk and shrink the overstretched, but you're just making work, and there's already plenty of that. I built up a collection of different shaped stakes to clamp in the bench vise. This one, made from a length of old fork stanchion, is about the same radius as the double curves we are trying to create to fit the frame tubes. Back at the buck, the edge curve is progressing well, but the panel rocks, needing more dish at the centre. More subtle shaping can be applied with the wheel. Pressure is adjusted from below via the roller cradle, but I have plans to convert to top adjuster soon, a rebuild which will include the addition of a pneumatic planishing hammer. That's something that would have been useful when making the tight curves of side panel, and will also be in creating a replacement for the perforated fuel tank. Steering metal through a wheeling machine is something that comes with practice. I'd liken it to reversing a trailer or riding a bicycle with your arms crossed on the handlebars. Everything is arse about face, but with practice a brain can be reconfigured. Wheeling also stretches the material, if not as dramatically. It sounds rough when crossing raw hammer blows, but soon the wheels begin to sing. Oh, for goodness sake, smile, or people won't know how much you're enjoying yourself. offering it up to the pattern to see where it fits and where it wants to spring away. Back to the stake and tap away, back to the wheel for further smoothing. Here it's not meeting the front of our pattern because the frame shaping doesn't quite run back far enough. Rework on the stake until it does. Occasionally you'll have a sense of taking steps backwards, but tell yourself that mistakes are also part of the learning process. And tell yourself again until you believe it. Each time you test and rework, you, the tools and the steel will get a little better acquainted, until, like old friends, you'll be happy to overlook each other's shortcomings for the sake of the good times you spend together. Once we get a really snug fit to the frame tubes, the piece can be clamped to the buck for a more accurate idea of how the rear is shaping up. Be fussy enough until you annoy yourself. Once all three sections agree with the pattern, clamp the sides on, lay the trimmed centre onto the two sides, scribe the edges and trim off excess. It seems that my excitement got the better of my filmmaking skill here, and I either failed to make a video of this stage or I lost it. So join me in my time machine at a point where I have tacked the three sections together and I'm starting to run full welds to the seams. A little filler rod helps. With welding complete, these are gently hammered on a stake and the excess sanded flush. Then the glass fibre pattern is clamped inside and the excess marked for trimming. Observant viewers may notice that the guard is already drilled for the rear number plate, the subject of a forthcoming part of this project, because we are fast running out of time today. The original guard has a stepped edge, its function both decorative and having a stiffening effect. I set up the bead roller to replicate this and run a trial on a piece of scrap. When I'm happy that it's a fair copy, I run the guard through, increasing pressure with each pass. Time for a trial on the bike and a look at attachments. The inner guard forms a stout support, and there are 3 bolts to the rear of tool and battery boxes, with a 3mm thick strap plug welded on to reinforce the edge. With positions marked and centre popped, I clamp, drill a couple of 3mm holes and make a temporary fixing with pop rivets to ensure alignment when drilling the rest. I'm not keen on assemblies with nuts in inaccessible places. They are fiddly to put together. Six threaded bosses are made from 19mm lengths of 12mm mild steel, drilled and tapped. I start the tap by footing it in the lathe tailstock and turning the chuck by hand to align accurately before I finish in the bench vise. To keep everything in line, the side panels are removed and bolted up to the rear tub before MIG welding, which is easier than TIG with such limited access. With hindsight, and I have oodles of that, silver soldering might have been a better option. Final work is to cut 2 slots where the lifting loop runs through to the frame. Another fiddle which requires some thought to ease assembly. In the next session we'll create that rear number plate assembly.